On April the 1st, 2026, 4 human beings sat inside a 14-story column of frozen propellant and pressurized fire, waiting for the countdown to reach 0. Ahead of them, the moon. Not a landing, not yet, but close enough to touch it with their eyes. This is the story of Artemis II, the mission that had to work, because everything after it depends on the fact that it did. To understand why astronauts strapped themselves to the most powerful rocket ever flown by NASA, you have to understand what came before them and what didn't. Between 1968 and 1972, 24 American astronauts left Earth orbit. 9 flew to the moon. 12 walked on its surface. It was, by any measure, one of the most audacious achievements in human history, accomplished with computers less powerful than a modern calculator. Then, on December the 14th, 1972, Gene Cernan climbed the ladder of the Lunar Module Challenger, looked back at the surface of the moon, and said the last words spoken by a human being standing on another world.
Composed of many fragments, of many sizes, and many shapes. When we return this rock, or some of the others like it to Houston, we'd like to share a piece of this rock with so many of the countries throughout the world.
He didn't know, in that moment, that it would take more than 50 years for anyone to return. Apollo ended not because it failed, but because it succeeded too completely, too fast, at a cost the country was no longer willing to pay. For half a century, the moon simply sat there, visible, unreachable, a monument to what humanity had already proven it could do and had chosen to stop doing. Why now? In 2017, NASA formally began a new program, named for the twin sister of Apollo in Greek mythology, Artemis. The goal was not simply to repeat the achievement of the 1960s. It was to build something that would last a sustainable, if difficult, human presence beyond Earth, using modern technology, international partners, and commercial industry in ways Apollo never could. But Artemis carries a weight Apollo never had to carry. In the 1960s, NASA was racing against one rival with a blank check and a single deadline. Today, the agency is racing against time, against a tightening budget, and against a new competitor, China, which has stated its own ambition to land astronauts on the moon before the decade is out. The moon, once again, has become a proving ground, not just for engineering, but for which nations will write the rules for how humanity operates beyond Earth. Before any of that could happen, NASA needed to prove something much more basic, that human beings could survive the journey at all, using entirely new machines that had never carried a crew. That proof would come in 2 vehicles. The Orion spacecraft, the crew capsule, built to keep 4 astronauts alive far from any hope of rescue. And the Space Launch System, the rocket built to throw that capsule toward the moon in a single, uninterrupted burn. Together, they represented the first new deep space human transportation system in half a century, untested, unproven, and about to carry a crew for the very first time. In November 2022, NASA flew Artemis I with no astronauts aboard, only sensors, mannequins, and cameras, on an uncrewed test around the moon. It was, by most measures, a triumph. Orion flew farther from Earth than any spacecraft built for humans ever had. But when the capsule returned and slammed into Earth's atmosphere at nearly 25,000 miles an hour, engineers found something they had not expected. The heat shield, the single layer standing between a returning crew and incineration, had charred and cracked away in patterns nobody had predicted. Chunks of it broke off during reentry, Not enough to destroy Artemis I because no one was aboard to need protection all the way to splashdown, but enough to raise a chilling question. What would have happened to a crew? NASA spent more than 2 years investigating. The launch date for Artemis II, once hoped for as early as late 2024, slipped to September 2025, then slipped again to April 2026. Behind those delays sat a much harder decision than any press release could capture: whether to fly the spacecraft NASA already had, or rebuild a heat shield years ahead of schedule and lose the moon program's momentum entirely. In December 2024, NASA's leadership made its choice. They would fly Artemis II with the same heat shield design, but they would change how Orion came home. Instead of a single steep plunge through the atmosphere, the capsule would perform what engineers call a skip entry, dipping into the atmosphere, skipping back out like a stone across water, and shedding speed gradually before committing to final descent. It was a redesign of the return trajectory, not the shield, a calculated bet, reviewed and endorsed by independent safety boards, that the danger could be managed rather than eliminated. Long before the heat shield problem, before the delays, before a single system was finalized, NASA had already made its most consequential decision of the entire program: who would be inside the capsule when it finally flew.
Ladies and gentlemen, your Artemis II crew.
In April 2023, NASA and the Canadian Space Agency introduced the crew of Artemis II. Reed Wiseman would command the mission, a former Navy test pilot from Baltimore who had already spent 165 days aboard the International Space Station. Victor Glover would serve as pilot, a decorated Navy aviator with more than 3,500 hours in the air, who in 2020 became the first black astronaut to serve a long-duration mission in space, and who would now become the first black astronaut to leave Earth orbit entirely. Christina Koch would serve as mission specialist, an electrical engineer who had once spent 328 consecutive days aboard the space station, longer than any woman in history at the time. And Jeremy Hansen, a Royal Canadian Air Force colonel and fighter pilot, would serve as the fourth crew member, the only rookie of the four about to make his first ever flight into space count as a journey around the moon. Wiseman and Hansen had trained alongside each other since 2009. These were not strangers assembled for a photo opportunity. They were colleagues who had spent over a decade in the same simulators, the same classrooms, the same high-stress training environments, long before any of them knew they would fly together. Between them, this crew carried 3 historic firsts: the first woman, the first person of color, and the first international astronaut ever to travel beyond low Earth orbit. But NASA had not built a symbolic crew. It had built a crew of proven operators, because a mission this unforgiving does not have room for anything less than total competence. For nearly 3 years, that crew trained for a flight that kept slipping further into the future. They practiced in a full-scale mock-up of the Orion capsule at Johnson Space Center, rehearsing emergency procedures, life support failures, and manual flying techniques they hoped never to need. They trained in the ocean, practicing what to do if Orion had to abort and splash down early, forcing Navy divers to pull them from the capsule in open water. They studied a spacecraft built by Lockheed Martin, powered by a European-built service module, atop a rocket assembled from components across the United States. A genuinely international machine, in more ways than the crew alone. Meanwhile, at Kennedy Space Center, the Space Launch System itself came together piece by piece inside the Vehicle Assembly Building. The same building, the same launch pad, once used to send Saturn V rockets toward the moon. On January 17, 2026, the fully stacked rocket rolled out to Launch Pad 39B for the final time before flight, beginning weeks of tests, rehearsals, and one final wet dress rehearsal in early February. A complete simulated countdown, loading 700,000 gallons of liquid hydrogen and liquid oxygen into the rocket's tanks to prove the vehicle was ready. It was not ready on the first attempt. A helium flow problem discovered after that rehearsal forced NASA to roll the rocket back to the assembly building, pushing the March launch window out of reach entirely. The crew, who had already begun a period of pre-launch quarantine to protect them from illness before flight, were released and sent home to wait. By the end of March, the rocket stood ready again. On March 27, 2026, the crew arrived back at Kennedy Space Center to begin final preparations. And on the afternoon of April 1, 2026, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen climbed into Orion, sealed the hatch, and waited. At 6:24 in the evening, Eastern Time, the countdown reached 0. The Space Launch System's engines ignited beneath them, generating more thrust than any rocket NASA has launched a crew on in the agency's history. In the span of a few violent, controlled seconds, 4 human beings went from stillness to speeds that would carry them out of Earth's atmosphere and toward a target more than 200,000 miles away. Minutes later, high above the planet, Orion's 4 solar array wings unfolded from the European service module, locking into place and beginning to draw power. A wingspan of over 60 feet, spread open in the vacuum of space. The spacecraft the crew had named Integrity was alive, and it was working exactly as designed. Hours after launch, with Earth falling away behind them, the crew performed one of the mission's most critical tests, a proximity operations demonstration, manually flying Orion by hand to approach and maneuver near the spent upper stage of their own rocket. It was a rehearsal for skills future crews will need to dock with landers and space stations, and a direct hands-on test of whether a human pilot could fly this new spacecraft with precision, not just let its computers do the work. Then came the burn that committed them completely. The translunar injection, the final major engine firing of the outbound journey, setting Orion on a free return trajectory toward the moon. From that moment forward, physics itself was carrying them forward, a trajectory shaped so that even in the worst-case failure, the spacecraft's own path around the moon would sling it back toward Earth. For the next several days, the crew lived a life no human being had lived in more than 50 years, sleeping in short, staggered cycles, waking to adjust their spacecraft's course, watching the Earth shrink behind them until it was no longer a horizon, but a single blue point in the dark. On April 4th, Christina Koch was photographed at one of Orion's windows, looking back at the planet she had left behind. A woman who had once set a record for the longest single spaceflight by a woman in history, now setting a new kind of record altogether as the first woman ever to leave the orbit of Earth. The crew's closest approach carried them around the far side of the moon, the hemisphere that never faces Earth, visible only to the small number of human beings who have ever traveled far enough to see it with their own eyes. For a period during that flyby, Orion passed out of direct radio contact with Mission Control, alone on the far side of another world, farther from human help than any living person had been in half a century. Jeremy Hansen had described before launch what that moment might mean to him. The extraordinary experience of looking back at Earth from beyond the moon, whatever that would look like, whatever it would feel like. Over the course of the mission, Orion and its crew would travel a total of 695,081 miles, farther than any human beings, including the Apollo astronauts, had ever traveled from Earth. On April 10th, Orion committed to its skip entry, the very trajectory NASA's engineers had redesigned in response to the heat shield charring seen on Artemis I. The capsule struck the atmosphere at tremendous speed, generating temperatures hot enough to vaporize most materials, dipped upward briefly to bleed off velocity, then committed to final descent, threading a needle that had been calculated, tested, and argued over for more than 2 years. At 5:07 in the afternoon, Pacific time, Orion splashed down in the Pacific Ocean off the coast of San Diego. Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen were home. The first human beings to return from beyond low Earth orbit in 53 years. Artemis II was never meant to be the destination. It was meant to be proof. Proof that Orion could keep a crew alive in deep space. Proof that the Space Launch System could launch humans safely. Proof that 50 years of institutional memory about deep space flight hadn't been lost. That proof now clears the way for what comes after. NASA's plan for the next mission in the program, Artemis III,